pleasure to introduce Dr. Lucy Rogers to you. My name is Colin Fee. For those of you who don't know me, I'm the head of the School of Product Design, and we're very lucky to have Lucy here as an Erskine Fellow at the school over the summer period. Lucy is a very well-regarded mechanical engineer from the UK. She's a Fellow of the Institution of Mechanical Engineers, also a Fellow of the Academy of Engineering, which is something which is a very difficult thing to achieve, and also has an MBE for her services to essentially engineering and or science communication, and promoting things, particularly through science communication. She's the author of a couple of books, one already out there, which is about, what's the first one?
Rocket Science.
Rocket Science, it's only Rocket Science, that's the title of the book. Which gives you a bit of a hint as to how she approaches things. It's always slightly quirky and innovative and interesting and makes things fun. And there's another book coming up fairly soon, which is called Up, A Scientist's Guide to the Magic Above Us. Lucy's here at the moment teaching a summer course, and it's great to see some of her students here actually today, which is a bit of a testament because they're actually getting more from the lecturer and have come along to hear her today. So the course she's teaching at the moment is called Gadgets and Gizmos, and it's for teaching people to just get interested in making the magic happen with tech devices. You don't have to have had any kind of background, but how do you make, for instance, a toy dinosaur respond to something on your iPhone? Can you program that to happen without any kind of programming background? So these are the sorts of things she does. Very interested also in sustainability, the natural world around us, and it's going to be a pleasure listening to what you have to say this morning, Lucy.
Thank you very much.
Do I take your seat?
No, you didn't. I left my laptop behind.
Today I'm going to share with you some stories. Stories of noticing things that others have not noticed, that spark ideas and opportunities. I've got stories about curiosity and how my interest in making, in community and play has shaped my career as an engineer, and how my luck has improved with seemingly unrelated and irrelevant things. At the end, I'm going to ask you to consider what unconventional skills that you may have that can drive problem solving, and how communities can foster knowledge transfer, and how design and manufacture can actually start to give back to the environment more than it takes. But let's just start with who's in this audience. So I've got some words that come up, or probably won't come up. I just put your hand up if you call yourself an engineer or a scientist. How about if you're in the humanities? And you can put your hand up to more than one of these. Creative, problem solver. Leader, organiser. Carer, community builder. Walk into things. Educator. How about if you're sporty? Musical. Curious. That's hopefully all of you. You're in today. Come on in. I'm just giving these as examples of how we put ourselves in boxes, and how sometimes we don't quite fit in one box and we have to make our own boxes. So keep that in mind as we go through. But we've also got within us things that we haven't been taught at school or university. So do I keep it to yourselves, but any of these might resonate with you. You might be able to juggle, you might be a dungeon master. All these skills add to what makes you unique, and I'll be talking about some of the things that I've learnt that haven't been formally taught. But now let me take you back to your childhood. Do you remember your favourite TV programme when you were a kid? For me, growing up in the 70s in the UK, there was a TV programme called Play School. And amongst all the other things they do for small children, we had the exciting thing of going through the round window or going through the square window. And they'd take you to places that, you as a child had never seen or experienced. So there might be kite flying in China. But my favourites were always the let's go to a factory. Let's go to the button factory to see how things are made. Let's go to the biscuit factory to see how biscuits are made. So my introduction to making was quite early on, and it has been a theme through all of my life. And with that, I was introduced to Heath Robinson, who made weird contraptions. If you haven't come across Heath Robinson, think of maybe Wallace and Gromit or Rube Goldberg. They're all of a similar ilk. So I was definitely more of the function rather than form. I would get something to work and it would not necessarily be pretty. I went to University Lancaster to study mechatronics, but I didn't get on so much with the electronics, so I stuck to the mechanical, and I was lucky to be sponsored by, they were at the time Rolls-Royce Industrial Power Group, and they made bits for power stations. And if you look on this middle photo, right down at the bottom, that's a person. So you can see the scale of some of the things that we were working with there. And I went all through the graduate training scheme. I learned a lot in different departments. And when I finally graduated the training scheme, the senior engineer said to me in a meeting full of people, "Oh, well, as far as I'm concerned, women can't be engineers." I knew then that maybe my career in that company was over. So I went and did a postgraduate course, the advanced course in design, manufacture and management, as it was, at Cambridge University Institute for Manufacturing. Now this was, for me, excellent. It took me to all over the UK and across Europe. And I'd go down a coal mine, we'd see how that worked. And we'd do some electrical wiring in a hydropower station. And I worked in a pottery and I worked in a steel mill, and I just had the most wonderful time finding out all these different things. After that, I worked for a small company that made firefighting equipment. So water cannons on tugs. They would be sending out, squirting out water if the fire was a normal fire, but a petrochemical fire. If you squirt water onto oil, the oil comes to the top and the fire doesn't go out. So you have to squirt foam onto it. And they had this piece of kit. So in the foreground at the top, the red is the water cannon, it's a water monitor, and at the back there's labelled branch pipe, that is where the foam is made. So there's a nozzle, it comes through the branch pipe with air is entrained through the holes that maybe you can see there. And then that is squirted out onto the petrochemical fire and puts the fire out. They had this piece of kit and they'd been working for about 30 years. No one knew quite how they were making the bubbles. So they couldn't work out, what do we need to change to make the bubbles bigger or smaller? How do we change everything to make it all what we want? So that was my role. I was the whole of the research department, and I got some small nozzles, and I made a branch pipe out of perspex, and I got hold of a high-speed video camera. Now this is one of the very early high-speed video cameras. It was on VHS tape, and it took up, the whole system took up the whole of the back of a station wagon, a Volvo estate. It was big and chunky. We had to get it insured. It was very, very expensive, but I was then taking videos at 40,000 frames per second of bubbles being made. And so I now you all want to know how are bubbles made. You actually know how bubbles are made. The first one, there is mixing. Small bubbles, so air is entrained as the nozzle squirts out the foam solution. and small bubbles are produced just by mixing, just as we would whisk an egg. And there were also larger lumps of air sort of caught up in that whole thing. So that's how most of the mixing occurred. And then when it came out of that nozzle, out of that branch pipe, it flew for quite a distance before it hit the oil, because obviously you want to be as far back as possible when there's a big fire going on. And during this flight, those air bubbles expanded, more bubbles were blown, just like a child's hoop, blowing bubbles, and the surrounding air was carried along with the jet. And the final method of making bubbles was a collision. Air caught inside the liquid that was going along, just got entrained, made more bubbles, and just like pouring a bubble bath, there was lots and lots more bubbles produced. So I was looking at things at 40,000 frames per second, and I could see things that no one had seen before, because not many people had looked at bubbles at 40,000 frames per second. I was working in industry, but it was actually in coordination with Lancaster University again. And they said, well, if you write this up, you'll get a PhD. I started writing. When I finally got the PhD, my supervisor, who'd known me since I was 18 and started at university, he said, yeah, you were never one of the ones we put down for doing a PhD. I was a B grade student. I wasn't showing myself off academically, but because I had the tenacity and because I did this work and because I wrote it up, I got a PhD. When I finished the PhD, I became a project manager at the company, and I wanted to go out on site. I wanted to help install some of these things. I wanted to see how they were used in real life. And the company told me that, no, you haven't got enough experience. So by this time I was about 25, I was a chartered mechanical engineer, I had taken apart and fixed my car multiple times, I'd done a lot of DIY, I was practical, and I'd built the whole test rig, but apparently I didn't have enough experience. So instead they sent the 21-year-old male graduate who just graduated, who had never picked up a spanner in his life, and who actually hated the whole experience. Again, I realised that maybe this company wasn't for me either. And so actually I ended up leaving industry for a while. But the things that I had noticed, that noticing the unnoticed is powerful. And I'm not just talking about what I did with a 40,000 frames per second camera. If we think of Ernest Rutherford, if we think of Alexander Fleming, they were noticing things that other people didn't notice. Maybe small things, but they can lead to big opportunities. I also realised that life has no mark scheme, and it is often unfair. So it was down to me to decide how I would progress with my career. I couldn't just sit in one company and just go up the system, because I would hit these barriers time and again. And at age early 20s, if you back then especially, if you started saying, hey, this is sexism, then you probably wouldn't get another job. So I didn't shout loudly about it. I am now. I'm shouting loudly now, especially when I see it. When I was, so I decided that, and I kept seeing that all these other people, mainly men, were getting opportunities that I wasn't getting. I was thinking, okay, life's not fair. How do I make it unfair in my direction? How can I load the dice? And I came across this attributed to Seneca. Luck is when preparation meets opportunity. So I had all these things going around in my head, and I decided I had to make decisions on my goals. I had to say what a good career was for me. I had to learn to load the dice of luck in my favour. So I changed Seneca's saying round, and I thought, no, actually, opportunities arrive when preparation meets luck. I learned that I had to learn from my failures and embrace those failures. At school, especially maths, we're taught that 2 + 2 = 4. If you get it wrong, you're bad. That's a bad thing. If you fail your exam, that's bad. But I was beginning to learn that actually trial and error and trying things was good. Now, while I was doing the PhD, because reasons, it was coming up to the year 2000, and there was a big computer bug that most systems wouldn't have coped with the change from 99 to 2000. And so I had a bit of a side hustle going on, working on this system. So when I left the company that made the firefighting equipment, I actually went straight into the computer consultancy. Oops, we'll go back to that. Which, the computer consultancy was very, very lucrative and very, very boring. But, money is good. And I now am very aware of the privilege that gave me to have a nest egg, if you like, to continue doing some of the other things that I wanted to do. So I continued with the computer consultancy, but I was always on the lookout for something else because I was bored. So an opportunity came. We are looking for scientists and engineers to work with the media, so the media know how scientists work and the scientists know how the media work. So I thought, I was filling in a tax return at the time, so it was like, yes, I'm off, I'm doing this. So off I go, and I actually, I got awarded one of the places with the Guardian newspaper. And I realised then, I think I should be, are we recording? Are we recording?
I do not know if it's being recorded, I'm sorry.
I'm going to press record just in case it isn't, which may or may not do anything. I'll put that on. So I started working at The Guardian, and at the time they had a section where readers would send in a question, and you could then, me as a scientist, would then answer it. So someone had fallen off a stepladder onto a drill, and it'd gone through their head, but they survived. And so the question was, how can this be? So I wrote it up and got it published, put in The Guardian, and I hadn't realised that I had this knack of turning science into English. I mean, helped considerably by the editor, the science editor, but once he told me a few tricks and hints, I really enjoyed this, taking the science that I understood and the engineering papers and actually putting it into plain English. And once I had a byline in The Guardian, other people would accept my work too. So I wrote some things and the BBC published it. So this was starting one of those untaught skill things of communication skills in writing. So I wasn't just writing reports for my peers, I was writing something that anybody could understand. But I was getting a bit worried, I was just doing this computer consultancy and I was out of engineering. And another opportunity arose. A company nearby was working on the Ansari X Prize. So back a few years, there was a prize, a few $1 million. Can you put a rocket into space and return it and send it back up into space within 2 weeks? So Spaceship One won this in 2004. But I was working on a company and they had no budget, they had no money, so I was volunteering. So I was volunteering at a company and we were working with rocket engines.
2, 1.
So you can see I had fun when I was doing that. And again, it was sort of, I wasn't getting money for this, but it was just another skill in my skill sets. But I was asking when I was there, I knew an awful lot about the nozzle design that I was working on, but I knew nothing about, well, how do you decide when you put it into space? How do you move it about when you're in space? What about all these other things? And they'd say, here's the textbooks full of that bit, and here's the textbooks full of this, and here's the textbooks full of that. And I opened them up and they were just full of maths equations. Now, I know I had done maths at university, but it never was quite my favourite thing. And I'd be working it out, you know, that's an integral sine, and that's the power of, and oh, what's A again? Whereas a lot of other people would just look at the maths and understand it, and I would just slogged through it. So I said, well, where's the introduction to? But there were children's books. How does an astronaut go to toilet in space? And then there were these textbooks. And then there was nothing in between. So again, I was noticing the unnoticed. And I thought, well, I want this book. So whoops, I wrote the book. Naivety is great. Ignorance is bliss. I actually managed to get a contract with Springer, who published similar types of books, and said, oh yeah, no, take me 6 months, year at the most. 3 years later, after an awful lot of slog, and a lot of swearing, and an awful lot of, oh, I didn't know that, and now I have to learn this whole new rabbit hole of stuff because of the unknown unknowns. And then, fortunately, my brother's a physics teacher, and I'd sent him chapters to proof, and he'd come back and say, yeah, you don't understand the physics really, do you? No. So with his help, I actually got this to be correct. And I was really chuffed recently. So it was in 2008 it came out. And I wrote it for me. I wrote that was the pure thing. I wrote it because I wanted to know. It's now being used in universities in the UK and in Europe. I believe someone recently told me it's being used by US Space Command. So to help the students, here's the facts, now let's hang the maths off in the second and third years. And it was recently voted in the top 10 of astronautics books for people wanting to go into it, which for something that I wrote for me, it was an unnoticed thing. I'm really chuffed with it. But I did swear that I would never write another book again because it was such a hateful process. About this time, I was also on Twitter. Twitter was quite new, and I found so many like-minded people talking about space, talking about engineering, talking about random other things, and these communities helped me share my ideas and spot opportunities, build connections, and all these things shape my career. And I remember someone saying, oh, what about all your invisible make-believe friends on Twitter? And I thought, actually, those make-believe friends are helping me. About this time as well, I was interested in astronomy as well as rockets, and I wanted to look through some big telescopes. But I didn't want to go all the way over to Texas for the Texas Star Party, and I was living on the Isle of Wight. Isle of Wight is a small island, a couple of miles, mile or so off the south coast of the UK. We had dark skies. So I had dark skies, and I wanted to look through big telescopes. Hey everyone, come to the Isle of Wight Star Party. And I invited people along, they brought their telescopes, I could look through people's telescopes, and again, we started this big community. And through that, I would approach manufacturers and shops and magazines saying, can I have sponsorship? Can we have prizes? And so I got a reputation in the UK amateur astronomy areas. And also, obviously, I put this stuff on Twitter, and I connected with a young @AstroKiwi, one of the space people. So this was, say, 15 years ago. I'm going to fast forward to February of this year. And I'm sitting at Heathrow Airport, and I put on social media, I'm now using Blue Sky, I don't use Twitter anymore. I put on social media, well, hey, I'm coming to New Zealand, I've been wanting to do this for 30 years. And AstroKiwi sends me a message and says, come talk to my students. Sure. So AstroKiwi turns out to be University of Canterbury, Dr. Michelle Bannister, Senior Lecturer above the bar of the School of Physical and Chemical Sciences. So over I came and talked to her students, and she said, oh, there's this thing called the Erskine Fellowship. Aha, click, right, opportunity. So quickly, I messaged whoever, the various people, and ended up with coming to the School of Product Design and saying, hey, what's this Erskine Fellowship about? Can I apply? And I have these 3 months free over Christmas. Can I do something then? So because I was on social media 15 or so years ago, and because I did this star party, I am now here teaching with an Erskine Fellowship. So I appreciate the Erskine Fellowship. Thank you very much. And about that time, I also got a puppy. She was called Enki, which is a German astronomer. And again, as I said, irrelevant and unconnected. Just you wait. So now, those skills that were not formally taught to me. I had some practical hands-on skills. I had teamwork, working at the star party, communication skills in writing, networking skills on Twitter, organisation skills, again with the star party, and caring for my dog. Then the Raspberry Pi was invented. Now, as I said, I didn't like electronics at university, but I did like the International Space Station. And on our star parties, we would say, oh, when's the space station coming out? And we'd all go out and we'd wave at the astronauts on the space station, because that's what we do for fun. On Twitter, you could get a message that said the ISS, International Space Station, is coming overhead in 10 minutes. I thought, that's great if you're on Twitter and you're scrolling, but what if you're not? I want a light to come on. So I was discussing it with some of my maker friends, and someone said, you need a Raspberry Pi. I said, I've got a Raspberry Pi, what do I do with it? And he talked me through, actually, he said, you need to use the GPIO pins. I said, yay! What are they then? They're the hedgehoggy type pins that are connected. So the Raspberry Pi computer, it's a $50 computer that basically had the same power of a computer of 10 years previously. And it was actually designed for children, because Cambridge University were discovering that people coming into doing computer science didn't have the skills that they'd had. And they said, well, why is this? Well, you don't give a child an expensive laptop to take apart. Whereas back when I was a child, the ZX81, you did take it apart and you did hack about with it and you did things to it. So I thought, can we make a small computer that children can play with? And if they blow it up, does it really matter? So that's what these were for, but hobbyists then said, go away children, we want it for our projects. So this was my first Internet of Things device. A tweet would come in, my Raspberry Pi would scrape that tweet, look at that tweet, and turn on an LED when the International Space Station was going across, and I'd see the light, and I'd go outside, and I'd wave at the astronauts. So that was my first experience of actually Internet of Things. And it was the first time that I had an electronic device or computer coding that did something that I wanted. And that sparked my interest, and I just carried on and carried on. So a bit later on, I broke my wrist, but I was going to a geek conference. So I made a little Christmas tree out of LEDs and neopixels. And you could tweet my arm to change colours. So anyone around the world was tweeting my arm, and my arm was then changing colour. And this is the sort of thing I'm now doing with the summer course here, Prod 385, Gadgets and Gizmos. So this is the sort of thing that I'm teaching the students so that they can make something that inspires them. And when I was doing this, also in my free time, I was competing in a local soapbox competition. So I was learning to weld, learning to be more creative, learning to have some fun. So the wheels here are wheelchair wheels, and the feet are actually bits of carpet spray painted orange. The thing I hadn't, lovely accidental thing, as the feet went round, they would go thwack, 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 thwack. And so as you're going down and getting faster, they'd go thwack, 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 thwack. Which was jolly. So, more skills I was acquiring. I think I'm just a collector of skills. So, opportunities arise when preparation meets luck. I hadn't actually thought that getting a dog would help me in my career. However, my neighbours, when their dog was pregnant, I got one of their dogs. And my neighbours happened to be the DeBell family. And so, I'd go for walks with them, my dog, their dog, we'd all go for walks, and I'd talk about the things that I'd done. Now, Alexander de Bell just happened to own a theme park on the Isle of Wight, Blackgang Chine, and he had some robot dinosaurs there that he'd got from China back quite early on when robot animatronic dinosaurs weren't really a thing. And he'd got these dinosaurs, but they'd gone wrong. And he said, I need help. You've been working with Raspberry Pis, can you do something? And I thought, well, probably not on my own, but I know people who can. So I put out a call on Twitter saying, right, we've got robot dinosaurs, we've got coffee, cake and pizza. Who wants to come and play? And I had about 15, 20 people come across. It was a win-win. And this is actually what happened.
My name is Alexander de Bell. I'm 5th generation de Bell family of Blackgang Chine. I've asked some people to come down and hack my dinosaurs.
Obviously, this dinosaur here came, and the rest of them all came with their own electronics and their own control gear. But what we wanted to do was to see what else we could do using the Raspberry Pi and get more control over it. We've got a few people down today for a Raspberry Jam, where they are having like a little hacking session, and they are learning a code in a program called Node Red, and they're going to use that to try and make some of our smaller dinosaurs do some cool things. The plan for day 2 is for the guys who've been learning Raspberry Pi today to use what they learned and make this dinosaur move in whichever way they want to. And make some sounds as well.
I'm modifying a box that Mark started work on yesterday. So he's already modified one of the dinosaur controllers to put a Raspberry Pi inside it, and that's worked really well. It's actually out in the park doing work for the customers of the park at the moment.
So in here we have the sensor input, which goes down to some simple circuitry to pull the voltage down to 5 volts. So it's like one of the inputs on the devices here, and then here are all the outputs that eventually through a relay goes to the motors through here and then out the through the
He wanted to carry on and modify some of the other dinosaur boxes to do the same thing. He couldn't be here today, so I'm carrying on today what he started yesterday. Other people in this room are working on the software to go on the Raspberry Pi, so when I finish the hardware, they'll load the software on, and that software will choreograph the movements of the dinosaur to actually make it a bit more sequenced than it was before.
One is an inject node, I mean you can inject a message into your program. So rather than having to have real sensors plugged into it, you can simulate it as just testing it out.
I've got a bit of a computer background, so I've got the basics of how things work, but obviously the language and that's all new. But the program that they've given us here is very easy.
So are you hopeful you can get a dinosaur to sing a song?
Yeah, no problem.
That's tomorrow's job.
Yeah.
Speech to it says, so I'll just put the dinosaur into it and set the pitch low, and then that's come out.
Can we hear it? Can I hear it?
I am a dinosaur.
What's happening? What's being done?
Basically, we've set it up on, it's on a timer, so like every few seconds it'll activate a different motor, and then we can also edit it so the sounds will come at a certain point like when the mouth opens, which we haven't done yet, I might add.
Oh, that is so cool! Oh, brilliant!
Yeah. Heal, now fetch.
one of the great things from that is we had a whole load of staff from Blackgang actually there, and they didn't have a technical team at the time, so we had the people who were parking cars, we had the chef, we had actually anyone who had any interest, so the theatre people coming in. So we had all different ideas coming in, and they were asking for different things that the geeks had never actually thought of, and saying, well, yes, we can do that. I don't know why we'd have wanted to do that, but yes, you want it, so we can make that thing. And it also, just by having this one training course of how can we control the dinosaurs, the Blackgang also took that idea and later put a connector onto the electricity going towards the motors on the dinosaurs. And so when the motor took too much current, it would send them a message saying, we think your dinosaur's broken, go look at it, or didn't take any current. And so they had this instant feedback of my dinosaur's broken. They didn't have to wait for a tourist to go around and say, here, your dinosaur's not working. So they had this instant thing just because of the way that we taught it. And because I was learning how to write things up and I wrote a blog about it, Raspberry Pi Foundation picked it up. And so they blogged about it. And then Farnell Element 14 also picked it up from that blog. It had gone viral at this stage, and so I was invited to go back to Blackgang and make some more videos for Farnell Element 14. But I had worked out somewhere along the line that I could write reports, but me giving presentations, I was so boring. And I went to Toastmasters International. So it is international. I had a quick look. There's 20 Toastmasters clubs in Christchurch, and it's a public speaking club. People who go along and give a 5-minute talk, and then the audience, who are also scared of public speaking, give their feedback and say, oh, I really liked how you did this thing, and did you know that you waved your hand around like this? This was me. No, I didn't know my hand was waving around like that. And you know, I liked how you did this. And from that, I began to realise that I had taken professional, giving a speech, to mean just the facts. There were no stories, there was no comedy, there was nothing. It was no wonder I was bored. The students must have been bored. So because of Toastmasters International, so I commend it to your attention. If you don't like public speaking, get to your local Toastmasters club. So opportunities arrive when preparation meets luck. So I'd done all these things, I'd done my Raspberry Pis, I'd blogged about it, I had this huge network on Twitter, and then one of my friends on Twitter was approached by BBC Robot Wars. Did she want to be a judge? And she said, no, it's not really her thing. But do you know Lucy Rogers? She has done dinosaurs, robot dinosaurs on the Isle of Wight. And so I had this interview and I had to show them, here's some videos that I've made, and because of the Farnell stuff, I had stuff online of this is me actually presenting to camera, this is what I've done. And so I became a judge on Robot Wars. Now, if you haven't heard of Robot Wars, here's a trailer for it.
Welcome to the Team Coyote application video. The robot was built just to prove that you don't have to be an engineer to build robots.
You've learned so much and are so keen to show the viewers how important it is to learn the arts.
This is the machine. The eyes.
We're going to start winning, okay? We're going to start winning bigly.
Classic power. I found something I can do.
I've been called boy genius and I really don't like that at all.
You've got to adapt your skills and change for the company.
Winning this is more for the people that say you can't. We'll either go down in the way to glory, or it will be.
So because I'd got a puppy, because I had played with Raspberry Pi, because I wrote about it all, I became a judge on BBC Robot Wars. You may not be able to tell from there how big these machines actually are. So there's some house robots. This is actually a little bit bigger than the actual robots. So the house robots were the ones who would come in and cause havoc if the fight already wasn't very havocable. This robot's called Dead Metal. And there were obstacles in the arena as well. And one of them was the pit. And if the robot fell down the pit, you were out. That is how big the pit was. There's the 3 judges. And I also had to explain some stuff to the presenters for camera. And here's me explaining, this is a Raspberry Pi, this is the robot dinosaurs we were using at Black Gang. And so all that went on to national TV. And that is Dara O'Brien. Twitter was still a thing, and Robot Wars gave me this huge, huge platform on social media. And I started talking to more and more makers. The Roboteers were makers, other makers, and we all sort of like saying it was a disconnected community. And I noticed again, there were guilds, societies, groups for woodturners. There were guild society groups for engineers. There were for knitters. But there was nothing for people who wanted to put it all together, who played with a whole load of things. So I set up the Guild of Makers for people who wanted to make things for a living. We started with Makers Hour. So Wednesday, 8 p.m. UK time, I would post various questions like, what have you made this week? What's your favourite tool? Whose work do you admire? And people from all over Twitter would come in, join in, and actually make connections and start talking to each other. And so this got bigger and bigger. I said, well, should we have a conference? Yes, let's have a conference. So I made a conference. And one of the wonderful things about having a conference and having this platform behind me was I could reach people. So I now know the founders of Arduino, the founders of Raspberry Pi, the founders of Node-RED, the software that we're using, MQTT, which is the software that talks to, or the protocol that talks to the internet. Rob Ives, who does paper engineering, he came and talked with us. And because of all this, I was asked by DK Books to do the forward for Inventor Lab books. So all these other opportunities just by making something that I, again, wanted. Sadly, it didn't survive COVID, but Makers Hour is still going. Someone else has taken that on, and every couple of years, there's this most wonderful geek festival. 4,000 geeks get together in a Deerfield that they're wired up so everyone has internet and power wherever they are in this 100-acre field or whatever it is. And it's just a joyous coming together of all things that people have made, big structures, small things, whatever. So it's a temporary town of creativity. And because of all this again, and because makers are makers wherever you are in the world, I have managed to go to maker spaces in India, in China, in Vietnam, across Europe, in North and South America, and of course here in New Zealand. And you just knock on the door, send them a message, say, hi, I'm a maker from the UK, can I come and see? Yes, come and show, when they show us everything that's going on. Back in 2008-9, when I wrote the book on rocket science, just as that came out, the European Space Agency did a call for astronauts. And obviously I applied, and I got absolutely nowhere. Fast forward to 2000, I think it was, 2002. Then the European Space Agency put another call out. And I was just under the age limit. So I'm gonna give it another go. And I got out my old CV that I'd sent in, and I looked at it and I thought, well, no wonder I didn't get anywhere. I wish someone who'd also looked at the criteria had seen that and helped me. So I put out a few messages and said, right, any women who want to swap CVs while applying to be an astronaut, let me know, and I've set up a forum. 340 women joined this forum, and we weren't just swapping CVs, we were putting ideas, and so I remember someone said, I've only spent a month in Antarctica, do you think I should put it down? And the rest of them were going, yes, yes, yeah, but all my colleagues have spent 12 months. It's like, yes, stop comparing yourself to your colleagues. Compared to people who are not your colleagues, that is amazing. Put it down. And it was just this most wonderful, positive, uplifting experience. So I think 23,000 people applied to become an astronaut. 1,000 got through to the first round. I got through to the first round. I failed on joystick control and memory. But it was such a wonderful experience. And a lot of this group is still going. People are meeting up at conferences and just building each other up, which has been, yeah, really lovely. So opportunities arise when preparation meets luck. And most of the time, most of my opportunities or most of the things that I have done have come about because I wanted it to be there. And who's going to make it if I don't? Well, I can't whinge on it. It's not made if I don't give it a go. And noticing the unnoticed, small details lead to big opportunities. And curiosity is an engineering tool. 7 years ago, Banksy, Girl with a Balloon, was being sold at auction. And just as they went going, going, gone, it started to be shredded. Hit all the news headlines. Why? How? What? Surely someone knew about this. Did anyone know about this? And I started looking at it, so thinking, okay, how did he do that? Have a look at this picture. So I was only using stuff that was available on the news. See the thickness of that frame? It's like, yeah, the people must have known that something was going on, because you don't have a frame that thick for a piece of paper. So, trying to work out what happened, I made one for myself. My remote control. So I said, yeah, it's possible, we can make these things. And so I tweeted about it, and it got picked up by BBC Radio 4 Today programme. And that's the flagship news programme of BBC Radio. And so I went on and I explained, you know, yes, it would have been planned, it would have been done like this, yes, it's possible, it wouldn't have been that difficult to do, he could have done it, he could have been anywhere in the room, someone could have just had the button to do it. And so that basically put me on a list of experts to go and talk on radio and TV about things science related. So last year, year before, I got a very unexpected letter in the post. The King would like to give you an award. And it's like, what? Really? Who sent me this? Is it an April Fool? You never know who nominates you for an award. I got an MBE. No one tells you what it's for, other than services to engineering, or who put you forward. But I'm pretty sure that if I'd not been doing, if I was not a fellow of the Royal Academy of Engineering, which was one of my personal goals, if I wasn't a fellow of the Institute for Mechanical Engineering, and I hadn't done so much explaining of science and forming communities, I wouldn't have got this award, which is, so I feel very privileged to have received it. So during lockdown, I felt I burnt myself out a little bit with too much making, and as soon as I could, I wanted to go travelling again. And I wanted to go and see a solar eclipse, and I wanted to go and see a rocket launch. I wanted to see all these things. I thought, who'll pay me to go and do all these things? So I put a pitch together, and I wanted to write about it, and because I've got some experience with writing, you know, 15 years have gone since my last bad experience with writing, so I thought, no, I can do this again. I got a book deal with Penguin. Basically, imagine you're lying on a picnic blanket and you're looking up, what brings you joy? So it could be a butterfly, it could be a rainbow, it could be a shooting star. anything. And I have taken 20 different things on the way up and looking at these different things. And I've made it slightly a travel book. So come with me to India to see Kite Festival where they're cutting each other's strings. Or come with me to Borneo to see 2 million bats come out of a cave. And and I happen to talk to a scientist, and here's some science that I'm putting into the book as well. So it's a popular science book for anyone. But when I was writing this, I noticed time and time again that people were saying, yeah, it's not like it used to be. We can't, astronomers can't see the stars because there's too many satellites going across nowadays. They can't take photographs of the stars, too many satellites going across. Or because we're digging up the environment, the butterflies that migrate for 4,000 kilometers from Canada down to Mexico, they haven't got enough to eat on the way down. And I was looking at these things and saying, okay, well, so we're destroying our environment, and manufacturing is one of the big problems. You know, making things, what can I do about that? I'm into manufacturing, I like the environment, what can I work on? And so I was just reading various books, and I came across the principle of carbon negative manufacturing. So we know carbon positive, you're putting more carbon into the air. Carbon neutral, you put as much carbon into the air as you take out of the air. But carbon negative is you're taking more out of the air than you're producing. But I wasn't just looking at this, I'm also looking at how can we give back to the environment? So not just in carbon, what else can we do? And there are some things that are already being done. So packaging out of mycelium, out of fungi. There's some glues being made out of mussel shells. Building materials, again, being made out of waste products, biological waste products like shellfish. And also willow weaving, where you coppice the trees. So this is where I started to look. So I'm now, when I go back to the UK in March, I am working with the Institute for Manufacturing at Cambridge, looking at different ways of carbon negative manufacture and how can we give back to the environment and not just offset it by planting a few trees. So my takeaways from what I've been doing, you decide your own goals. And if you learn some things that others don't, so if you're an engineer and you start to learn, music, you're making yourself unique. And the more other things that you learn, the more unique you are, and the more skills you can give to whatever you want to do. Being curious, notice the unnoticed. Become an active part of a community. Don't just lurk, actually give something and ask for something. Play. Play for me has been so important, and a lot of things that I have done have led to other things because I've been playing. Explore and ask for opportunities. Opportunities don't land in my lap. Often I have to do something, I get an inkling of an idea and I have to go out and chase it and say, look, I've done this, this and this, give me the opportunity, give me the opportunity. And make your own luck. So I'm challenging you to think about your unconventional skills. How can that help with problem solving? What communities are you in, and how can you contribute to that knowledge exchange? And also have a think about how can design and manufacturing evolve to give back more than it takes. So speaking of making luck, I'm really enjoying this fellowship here in University of Canterbury and the whole of New Zealand. So if anyone has a Lucy-shaped role that they want for maybe 2027, let's talk about it. I challenge you, notice, create, connect, and have fun along the way. Thank you.
Thank you very much, Lucy. I knew the talk was going to be entertaining. You didn't disappoint. There's time for a couple of questions. If you have questions for Lucy. I think I'll kick it off in that case. I was thinking if you look back to your 18 to 20-year-old self studying your engineering degree, what would you do now if you were delivering such a degree? How do you encourage this kind of thinking throughout that very prescribed, professional, career-oriented degree?
It was very dry and I didn't see the practical applications. And that for me would have made a big difference of this is how you actually apply this thing. You know, we're learning matrices. Why are we learning matrices? What am I going to do with these matrices? How